Okay, so we're starting the new unit, and the beginning of it covers a lot of stuff that was covered already in Algebra 1. So you can see I already have a few things filled in. I'm going to just kind of highlight some of the quick details that we talked about with Boxplots from Algebra 1. And this video is really going to focus on how to input data into a calculator. For a box plot, we need the 5 statistical summary, which consists of the minimum, the maximum, the quartile 1, the quartile 3, the median. These quartiles also have other names, such as the 25th percentile for the quartile 1, the 75th percentile for the quartile 2, and the 50th percentile for the median. Other names also include the lower quartile for quartile 1, as you can see in the box plot here, and the upper quartile, as shown here in the box plot. So we have a picture of an example here comparing the ages of Oscar winners, comparing males to females. And you can see that something new is happening here, although we really don't have to concern ourselves with it too much. And you see that we have these stars, these asterisks, which represent outliers. So the majority of the Oscar winners for females were in the range of, I don't know, this looks like 21 here, up to about 49 or 50, whatever that is right there. But then there were 3 that fell outside that range, and they were so far away from the majority that we can put them in there as outliers. And the calculator can do that for you in specific cases. Whereas the males, you can see they have a cluster in the range of about 29 to 62, and then they're one outlier that looks up there just below 70 or just below 80. So the first few questions here are answered already. I'll just highlight them again. Which gender has the larger median? That would be the males. And you can see that that's this line compared to this line, and I would estimate that to be about 42. Which gender has the larger range of ages of Oscar winners? So if I take the females and I do the max minus the min for this example, the highest or maximum value looks like it's at 80. And the minimum, if I had to estimate, looks like it's about 21. So if I do 80 minus 21, that's going to be 59. So that's the range there. Then the third question here is which gender most likely has the largest mean age, and that's the males. I know that the mean is not present in a box plot, but you can kind of tell just by looking at it. The mean and median should be relatively close to each other. The median is at least 5 years higher for the males, so that's why it is believed that the males have the higher mean. And in fact, for the males, the mean is greater than the median because of the fact that we have 50% of the data on this side and 50% of the data spread out a little bit more on this side, plus this one outlier over here. So this outlier kind of pulls the mean in this direction, which is referred to as data being skewed right. And so the mean is skewed to the right and therefore greater than the median. So on the next page, we have Owen and Grayson, who have test scores. Owen's are 80 and 70, and the average of those two scores right in the middle, 75. Grayson's are 50 and 100, and the average of those two scores, 75. If we just look at the averages, if I said Owen and Grayson have average scores on their tests of 75 without knowing any other details, you would say that they scored the same or similar. However, once we kind of think about the idea that the two scores that Owen had were only 5% away from the mean, and Grayson's scores were 25% away from the mean, then you would say that Owen is more consistent. And that calculation that we just came up with there is what we call the standard deviation. There is a special symbol for standard deviation. We're going to find it on the calculator. And that symbol is the sigma symbol, right? So this is a lowercase sigma, right? We're used to this sigma as the sum. And in fact, standard deviation is found by doing a sum. I'm not going to go into the formula for it because the calculator does pretty much all the calculations we need. And so we're not going to really worry about it. So in example 3, we have a data set where we are asked to find the mode, median, range, interquartile range, mean, standard deviation, and sketch a box plot. So mode cannot easily be done on a calculator, but if what you remember from back in middle school is that the mode is the most common value, and 47 is the only number in this list that occurs twice. You could have 2 modes, 3 modes, no mode. You know, if everything occurred the same amount of time, then you could have no mode. So there's that. So the median, I'm actually going to let the calculator take over at this point. So what I'm going to do is pull up my calculator screen here. I'll slide this over to the side, and I'm going to start a list and spreadsheet. And so usually we have to name our list something. These are test scores. So maybe I'll put a T here for test. I could actually write out the whole word, but not having a QWERTY keypad down here, it's a lot easier to just use a single letter. So the scores we have are 43, 46, 47, 51, 54, 59, 61, and I missed one. You can see that I forgot to type in the number 47 twice. The nice thing is I don't actually have to get this in the exact order that was listed there. So if I just tack on the 47 at the end, that's okay. And so now what we're going to do is we're going to go to Menu, Statistics, Stat Calculations, One Variable Statistics. The number of lists will always be 1. We have 1 list here. So we go to the X list. I could type in T for test, or if I cursor to the right, I could see that it's dropped in there. And then instead of scrolling all the way down, I could just hit the Enter button on the calculator, and there's all the information we need. So the next question was the median, and the median is 49. Now, obviously, we have that as an answer here on the calculator, or I could have just calculated it by saying, well, right in the middle is the median would have fallen right there, halfway between 47 and 51. It's 49. The range is the max minus the min. So that is 61 minus 43. And that is 18. The interquartile range, well, in order to figure that out, I need the 2 quartiles. So if I go back to my calculator screen, you can see our 5 statistical summary here. The min, the quartiles, the median, and the max are given, and 46.5 and 56.5. So to subtract those values, 56.5 minus 46.5, which is just 10. The mean, now we have to find that. That has a special value or a special symbol on the calculator. It's the X with the bar on it. So this is one of the symbols we could use for mean here. That's 51. The standard deviation is 6.062, right? So there's that symbol that we talked about for the standard deviation. To the nearest tenth, that would be 6.1. Now, E and F are not going to be used for part G here, or nor will the mode. But you can see I already have a number line plotted out. The minimum is 43, so I'm going to estimate that to be right there. The lower quartile is 46.5. So I'm going to start drawing the box there. The upper quartile is 56.5, so I'm going to close the box off right there. So there's the box for the box plot. And the whiskers. The median was 49, so that's just shy of 50. And the maximum was 61. And so you can see that there. I could also put a box plot on the calculator if I go to, if I add a data and statistics page, and I have the data floating around right now, I need to tell it how to organize itself by putting T along the x-axis. And then if I go to menu, plot type, Boxplot, it automatically slides into that, and you can see all the same data, the minimum, quartile 1, median, quartile 3, and the maximum. All right, so then the next question is one where we have to accommodate a frequency list. And so I'm going to actually start a new document here, and I'm going to add a list and spreadsheet. I'm going to put in 2 columns of data, and right, one is for the scores of the golfers, and one is for the frequencies of those scores. So we have in the first column 70, 73, 75, 80, 85, 86, 90, and 92. And then what I need to make sure is that the frequency values line up perfectly with what their counterparts are on the left side there. So 4, then 3, then 2, then 3, then 1, then 1, then 2, then 1. So now when I go to run my one variable statistical analysis, so statistics, stat calculations, one variable statistics, number of lists is still 1. It's always going to be 1 for what we do. And then here is where I actually input the frequency list. The frequency list I labeled as F. So where it says frequency list, I changed that from a 1 to an F. And then again, if I just hit enter without scrolling all the way down, this is how I know I entered it correctly. N is 17. And in the question, it said that there were 17 students on the high school golf team. If I forgot to put the frequency list in, it would have given me N was equal to, I think, 8 or 9. All right, so we need the mean. The mean to the nearest whole number in part A is 78. And the standard deviation to the nearest tenth is 7.49, which rounds up to 7.5. How many of the students' golf scores fall within 1 standard deviation of the mean? So we are going to be doing 78 plus or minus 7.5 to come up with a range of values. So if we do 78 minus 7.5, we get 70.5. If we get 78 plus, you end up getting 85.5. And so we need to figure out how many scores fall within that interval. So I'm actually going to make this a bigger screen again. And 70.5, 70 would not be calculated on that list, but 73, 80, 75, 80, 85, all these scores will be calculated on that list. So I have to add up those numbers, right? Those frequency values tell me how many times those scores occurred. So 3 plus 2 plus 3 plus 1 is going to be 9 students. All right, I think that's where I'm going to stop for this video and leave the rest as an exercise for you guys.